Okay, so let me solve this problem for you. So I will solve this problem from Matematik or 5, 1245 on page 35, and then one more problem, and then you are free to work on yourself for the exam. So if you remember, I started talking a little bit about this. So let me summarize this a little bit. If I remember correctly, I called the right-hand side Bn, and I called the right-hand side An. I want to show that An is equal to Bn. It is equivalent to show that An minus Bn is equal to 0. So they are the same. So my point, the statement Pn that I want to show that An minus Bn is equal to 0. So this is the statement that I want to show using mathematical induction. Okay, so the first thing that I need to check is the truth of P1, yes? So what should I write? P1 means A1 minus B1 equals to 0. So this is what I need to check, if this is true or false. Okay, but what is A1? A1, if you put 1 here, this becomes 1 times 2. So that's the first term. So it's 1 divided by 1 over 1 divided by 1 times 2 is equal to. So do you remember what is B1 here? So B1, do you remember I told you that this 2n means n plus n. So this will take n from you and start adding 1 to it, 2 to it, until it reaches to n plus n again. So now n is equal to 1. So I will start with 1, and then I start adding 1 and then 2 until I reach to n again. But n is 1, so when I write 1 plus 1, I have to stop there. Yes? And then this is completely clear. This is true, yes? Because this is 1 over 2. This is also 1 over 2, so this is true. Okay, so this is true, so this means P1 is true. Yes? Now we assume that Pk is true. So let me just write it like this. So I assume that Ak minus Bk is equal to 0, assumed to be true. Okay, and then I want to show that Ak plus 1 minus Bk plus 1 is equal to 0 as well. That's my goal. Yes, is that okay? So if I can show this based on this assumption, then I am done. Okay, so let me start from the left-hand side of what I want to show. So the left-hand side is equal to A sub k plus 1 minus B sub k plus 1 is equal to. So I need to be able to write A sub k plus 1. Okay, so that is not important. So it's very clear for you what to do. I need to replace n with k plus 1 everywhere on the left-hand side, for example, here. So it becomes 1 over 1 times 2 plus 1 over 3 times 4. And then it will continue until I reach to, instead of n, I put k plus 1 in brackets. So let me write it here. So it's 2 times k plus 1 minus 1, which becomes 2k plus 2 minus 1, which is 2k plus 1. And the next one becomes 2k plus 1, which is 2k plus 2. Yes? So then the very last term is 2k plus 1. Yes, 2k plus 2. But of course, if I ask you what is the previous one is exactly that expression for k. Is that understandable? What I have written is just a sub k plus 1. Minus, let me open a pair of brackets to write bk plus 1. But what I want you to tell me, what should I write for b sub k plus 1? Yes?
1 over k plus 2.
So how do you think about this? So because you see here, if I give you n, you take the same n that I give you and then add 1 to it. The next step, add 2 to it, and then you continue until you add n to it. Yes, yeah. That's the idea. Now I have given you k plus 1, so it means that, let me write it. So you take k plus 1 from me. You take that one, and then you add 1 to it. Yes, and then what you do for the next step, you add 2 to it, and then you continue until you reach to which step? When do you stop? So let me just interpret. You see, when I give you n, you write 1 over that n plus 1, plus 1 over that n plus the next number 2, and then you continue until you reach 1 to that n plus n, and then you stop. Instead of n, I have given you k plus 1. So you write 1 over k plus 1 plus 1. The next one is 1 over k plus 1 plus 2. And then you continue until you reach to which step and stop? Yes, Luba?
K plus 1.
K plus 1. Yes? Okay, now this is the stopping point. But can you tell me what is the previous one? What is the previous one? Yes?
The same, but plus k.
Plus k, yes, because this k plus 1 remains the same all the time. You see, this n remains the same until the very end. So this becomes k plus 1, and then this becomes k. And even if I ask you what is the previous one, you can also answer. It's 1 over k plus 1. The previous one is k minus 1. Is that understandable? You see, you're not allowed to change this k plus 1. K plus 1 remains fixed until the very end, but what is changing is the number that you are adding. You start adding from 1 to up to k plus 1. But if you're going one step at each time, it means that you reach to k minus first step, you reach to the k step, and then you reach to the k plus first step. And then you close. Is that understandable? So this is ak plus 1 minus bk plus 1. I want to show that this expression is equal to 0. Okay? But now I am asking you, and what can I write instead of this part? What is this? It's exactly the same expression. Instead of n, I have k. Yes? So from here to here is just ak. Yes? But now the problem is that you need to organize it a little bit. So here, this is, so let me write it one more for you. So this becomes equal to, instead of this part, I write ak, and then I have plus 1 over 2k plus 1. So let me factor a 2 out. K plus 1, 2k plus 1. This is what I have written here. And then when I go to the pair of brackets, so you see that this k plus 1 becomes k plus 2, 1 over k plus 2. The next one would be 1 over k plus 3. And then you continue until you reach here, which is what? 1 over 2k, because minus 1 and 1 are canceled, so k plus k is 2k. And the next one is 2k plus 1. And finally, the last one is 2k plus 2. Do you agree? In order to be able to use the assumption, I need to make bk manifest itself here in this calculation. ak has already manifested itself. Here I have ak, but this is not exactly bk. There is one term missing, yes? Do you agree with me? Because if I ask you what is bk, it is easy. Bk means just replace n with k everywhere. So you get 1 over k plus 1 plus 1 over k plus 2 until you reach to 1 over 2k. So there is one term missing there, yes? Is that understandable? It starts from k plus 2, yes? So what can I write instead of this expression if I insist to write something in terms of b for this? Yes?
Bn minus 1 over k plus 1. Right?
bk, yes? Not bn. bk minus 1 over k plus 1. Is that understandable? So you see, if I ask you what is bk, you would write 1 over k plus 1 and then 1 over k plus 2 until you reach to 1 over 2k. I have all those terms here except the very first one. So if I say this is bk, you will not accept it from me because there is one term missing. But if I say this is the whole bk minus the first term, then that's okay. Is that understandable? Okay, now this is good because now I can somehow use the mathematical induction, the hypothesis. So it becomes, the assumption. So this becomes a over k. This, let me write it as 1 over 2k plus 1, 2k plus 1 here. And then I apply this negative sign inside. This is positive bk. After being applied by this, it becomes negative bk. This negative will apply on this one as well, so it becomes 1 over k plus 1. And then there are two terms left, this one and that one. So apply negative sign there. I apply negative sign there. And if you don't mind, let me here factor a 2 out. Everybody understands what's going on? Okay, now let me just reorganize that. I write ak minus bk next to each other. And then the rest of it, I put in a pair of brackets. So 1 over 2k plus 1, 2k plus 1. I have plus 1 over k plus 1 minus 1 over 2k plus 1 minus 1 over 2 times k plus 1. Agree? And but if I ask you what is this one, what's your answer? Yes?
0.
It's 0 based on the assumption. Yes? So I'm using the assumption. So this is 0. So if you want to see why, this is because of that. So it means that I need to do some algebra to make sure that this part is 0 as well. Why? Because my goal is to show that this is equal to 0. I started from the left-hand side. My goal is to reach to this idea that this is equal to 0 as well. So what I need to do is just simplify this expression. For simplifying this expression, I have some fractions involved. So I need to take the common denominator, yes? So this becomes equal to, what is the common denominator between all these terms? It is clear that this one will play the role of the common denominator. It has all the factors that I need in all of them, yes? So this one divided by this one is 1 times, I multiply 1 here, it becomes 1. The next one is plus. I divide this by that one, k plus 1 and k plus 1 are cancelled. 2 factors are left, 2 and 2k plus 1. I have to multiply that in the numerator, yes? So it becomes 2 times 2k plus 1. The next one is negative. If I divide this in my head by that one, 2k plus 1 and 2k plus 1 are cancelled, and 2 times k plus 1 is left, then multiply it in the numerator, so it becomes 2k plus 1, yes? And then if I divide that one, this one by that one, 2k plus 1 is left. So I have to be careful about these signs. Hopefully I have done everything correct. So if I calculate this, I expect that this becomes equal to 0. So it means that I need to be sure that the numerator is equal to 0. So let us take our chance to see how it goes. Yes, so it becomes 1. I multiply 2 inside, it becomes 4k plus 2. I multiply minus 2 inside, minus 2k minus 2. I multiply the negative sign inside, minus 2k minus 1. And the denominator, I just keep it as it is, yes? Let us see how it goes. Yes, everything vanishes now. So 4k minus 2k minus 2k is 0. 1 plus 2 is 3. Minus 2 is 1. Minus 1 is 0. Yes, so this becomes 0 divided by 2k plus 1, 2k plus 1. And then you know that the fraction whose numerator is equal to 0 is indeed equal to 0. And that's equal to the right answer. Yes. So I would say that this is really a level 3 problem, I think. So it was not that trivial, especially if you misinterpret how you need to write bk and bk plus 1. Yeah, is that okay? Everybody understand what's going on? Okay. I just want to solve one more problem, and then we are done. That's also for number theory. I gave 2 examples, I think, or 3, I don't remember exactly. But let me add 1 to it, and then we are done. Okay, so let me write the example here for you. Example. Show that for every natural number n, so 3 divides this number into the 3 plus 2n. Okay. So we want to show that for any natural number n, this is divisible by 3. Yes? So if you want to use mathematical induction, of course, so let me write, because use induction, yes. You can also use modular arithmetic to prove this. Okay, so if I want to show that, so for n equal to 1, P1 means 3 divides 1 to the 3 plus 2 times 1, yes? So this is equivalent to say that 3 divides 3, yes? Because this is also 3. And that's a true statement. Now we assume that this is correct. This is true for k. So 3 divides k to the 3 plus 2 times k, assumed to be true. And then we want to show that pk plus 1 is also true. So we want to show that 3 divides k plus 1 to the 3 plus 2 times k plus 1. This is the question. Usually, for this one, it is better to simplify this algebraically a little bit, yes? Because then it would be easier for us to understand what to do. So, I don't know, do you remember there was a formula that I mentioned before? So we have a plus b to the 3 becomes the first one to the 3, 3 times the first one to the 2 times the second one, plus the 3 times the first one times the second one to the 2, and the second one to the 3. That's also given in the formula sheet, okay? So let me try to simplify this a little bit. So this statement itself is equivalent to saying that 3 divides, I use that rule for this one. K will play the role of the A, 1 will play the role of the B. So this becomes K to the 3 times the first one to the 2 times the second one, which is 1 in this case, plus 3 times K. The second one to the 2 is still 1, doesn't matter. The second one to the 3 is 1 again. So that's the expansion of the first term. And then I have 2K plus 2, so let me multiply it. So it becomes 2K plus 2. But then let me simplify this algebraically a little bit. So K to the 3 is alone, so it becomes 3 divides K to the 3. And then I have 3K squared, that's also alone. So 3K squared, and then I have 5K plus 3. So K to the 3, 3K squared, 5K plus 3. I'm supposed to show that this is valid. So my assumption is that 3 divides this, but I want to show that 3 also divides that. Yes? That's my point. So instead of proving this, I showed that this is equivalent from a mathematical point of view to this one. So instead of focusing to prove this, I will focus to prove this one. Okay, and then I think it's easy. It's not hard. So if you have forgotten the theorems, you don't need to remember them. You just use the definition of divisibility, yes? Okay, so what can I do? I can start from my assumption. I know that 3 divides K to the 3 plus 3K. So according to the definition, there exists a cube in the set of integers such that K to the 3 plus 3K is equal to 3 times Q.
2K.
Yes? Is that, yeah?
2K.
Ah, okay, thank you very much. Yeah, that's very helpful. It's 2K. Thank you. Okay, so we know that K to the 3 plus 2K is 3 times Q. But what I want to conclude, I want to conclude something about the divisibility of this expression by 3. Yes. So what can I write? So now, therefore, K to the 3. Here we have 3K squared. Yes. And then I have plus 5K. And then I have plus 3. This is the one, I have it here. I want somehow to write it in a way that I can use that piece of information. And I don't think it's hard. How should I write it down? I want to write this in a way that I can use this piece of information. That piece of information is related to the third power of K plus 2 times K, which is not exactly here, but I can rewrite this in a way that I can see that, yes? So what should I do? K3 is good because I need it. I need 2K. I have 5Ks involved, yes? So what can I write? I can write 2K here. And then what is left for me? There are terms left for me is 3K squared. And there is a 3K here and a 3 here, yes? These are left. So do you agree that this one is equal to this one? So I have just broken this term into 2 terms. But it is done yet now, yes? Because I know this part is a multiple of 3. So this becomes 3Q. And then what is left for me, all of them has a factor of 2. I have a factor of 2, yes? So if you see, I can factor a 3 out from all what is left. So it's this one. And then this one is guaranteed to be an integer, yes? Because Q is an integer and K is a natural number. So this combination is definitely an integer, yes? And I have multiplied an integer by 3 and it is equal to my expression. So this means that this expression is a multiple of 3. So therefore, hence, we can get 3 divides K to the 3 plus 3K squared plus 5K plus 3. Yes? So that's also something that I want to mention. Just before finishing, let me refresh your memory. If I want to prove this using modular arithmetic, that's also possible, might be a little bit easier even, okay? So do you remember how can I do that? So assume that you want to prove it. If I have emphasized in the exam use induction, then of course you have to use induction. But otherwise, if you want to prove it, that's your choice to choose induction. Usually induction might be a little bit more lengthy, but you don't need to be so creative because it's algorithmically. You can just start from and then follow some steps and then you prove. But of course, if you're a little bit more creative and more experienced, might be you can find a way out of it by proving this. Okay, so let me, for refreshing your memory only, so let me change my color. Assume that I want to show this using modular arithmetic. So do you agree with me that n in modulo in the third module can be written as 0 or 1 or 2? Do you agree? Because any number, so you know that if n is a number, if you divide it by 3, there are 3 possibilities. Yes, either the remainder is 0, or the remainder is 1, or the remainder is 2. Do you remember? If you divide a number by 3, there are only 3 possibilities. Either the remainder is 0, so it means that my number is a multiple of 3, or it's a multiple of 3 plus 1 because the remainder might be 1, or it can be the multiple of 3 plus 2. But multiple of 3 plus 3 is again 3 cubed. Yes, it goes back. So there are 3 possibilities. So if this happens, this is 0 in modulo 3. Modulo 3 is 0. This means that n is 1 modulo 3, and this means that n is 2 modulo 3. So that's, if you have forgotten, that's important to remember. Okay, so this means that if n is this, then n to the 3 plus 2n is also 0. Yes, because if n is congruent to 0, if I raise it to power 3, it remains 0. If I multiply it by 2, it remains 0. If I add them, it remains 0. So if this happens, then I am done. Yes? So this means that here I am done. If n is congruent to 1, then what happens? Then n to the 3 plus 2n, instead of n, I put 1. So this becomes equal to 3, but 3 in its own module, it is 0. So again, the remainder is 0, so this means that 3 divides n to the 3 plus 2n. So in this case, that's also done. And then finally, if n is congruent to 2, then n to the 3 plus 2n, instead of n, I can replace 2. I can substitute 2. And then what will happen? Okay, this is also 8 plus, yeah, that's 12. But 12 in the module 3 is again 0. So it means that in all possible cases, I confirm that this expression is divisible by 3. So this is a method that you can use to prove this statement without mathematical induction based on modular arithmetic. And that was the using induction, yes? So that's also true. So it means that in all possible cases, these are the only possible cases for n. I showed that in all possible cases, this statement is a true statement. So it means that in all possible cases, it's a true statement. Yes? So this is the proof for this without using mathematical induction. So that's also good to refresh your memory about these ideas. Okay. Now everything is covered in first chapter, so I will not teach anything the rest of this session, and on Thursday you can have practice, and on Monday we will have the test, okay? Thank you.
Yeah.